Hi gentlemen, page number 183. Question: should a maneuverable boiler unit be compact? Answer: a maneuverable boiler unit should be compact so that it contains a small mass of metal. With a lower mass of metal, less time is required for startup and changeover from one thermal mode to another. Question: why are maneuverable boiler units usually fuel oil fired? Answer: maneuverable boiler unit should essentially possess the capacity of rapid changeover from one thermal state to another. In case of fuel oil fired boilers, this basic condition is easily met as the fuel oil combustion is efficient as well as stable over a wide range of operation loads. Question: why are the convective elements of maneuverable boilers made with a horizontal arrangements of tubes? Answer: a maneuvering boiler unit should be drainable for maintenance convenience. This being the case, the tubes are arranged horizontally in the convective heat transfer elements. Question: why is the working fluid in a maneuvering once through boiler circulated at high mass velocity? Answer: to ensure proper cooling over wider range of loads, reliable operation of a boiler at low loads. Question: it is true that the efficiency of monoblock unit and a thermal power station is a function of the initial steam parameters. What technical difficulties inhibit the possibility of increasing the temperature and pressure of the steam infinitely? Answer: 1. The first deterring factor is the availability and cost of the special steels that will operate reliably at higher parameters of superheated steam for prolonged periods. 2. The cost of metal in the superheater and pipelines increases sharply with increasing temperature. 3. For generating subcritical pressure steam, natural circulation drum type boilers are usually employed, and with the increase of pressure the driving circulation head increases so that the highest pressure in the drum is established at 17 meganewton per meter squared so as to ensure reliable circulation. Therefore, a higher pressure may tell upon reliability. Fourth one, the most deterrent factor in selecting higher steam pressure is the cost of the boiler drum. For a high capacity drum type boiler, higher steam pressure means a drum of larger dimensions and wall thickness. With the addition of more metal, the cost of drum mounts. It becomes very heavy and bulky, which presents considerable difficulties in mounting and operating the boiler. Question: what are the consequences of overloading a boiler? Answer: it will affect the design circulation velocity, result in higher flue gas temperature, bring about higher superheated steam temperature that may lead to superheater coil failure by bulging or overheating. A boiler is never guaranteed for running at overload. Question: why is it not advisable to run a boiler at part load? Answer: constant running of a boiler at part load will cut short of its life due to a rapid wear and tear. Question: what are the effects of running monoblock unit at derated pressure? Answer: if the boiler of a monoblock unit having turbo alternator in line runs at a derated pressure. 1. The pressure of the steam inlet or to turbine will be low, and that will consequently reduce the output of the turbine. Of course, at the steam pressure drop of 5 to 10% will not affect the TA output much. Second, the specific volume of steam will increase, but as the boiler and piping design are constant, the rate of steam generation will drop and steam supply will be lower. 3. Overall thermal efficiency of monoblock unit will be less. Question: why is carbon dioxide percentage in the flue gases measured? To detect whether the flue combustion within the furnace is complete or not. Fuel combustion. The next question: what are the reasons for black smoke emission through the chimney of a spreader stoker. Answer: incomplete combustion of fuel in the furnace and disintegrated carbon particles being released without being completely burned in the furnace. Carryover of coal fines due to excess of its percentage in the coal feed. Low supply of secondary air that would otherwise complete the combustion. Question: what is the problem coal segregation encountered? Answer: in a stoker fired furnace. What is it? Answer: clogging of coal feeder of or chain grate due to large size of coal in the former case, or higher percentage of coal fines in the feed later case. Question: why does coal segregation occurs? Answer: segregation will occur if coal contains a higher percentage of fines. Second, the design of the coal bunker is not proper and the bunker sides are not sloped to 40 to 60 percentage of for proper rolling of coal feed. Third one, the coal size is more than 23 centimeter. Question: where is the fire slippage encountered? Answer: in the stoker fired furnace. Why? Answer: if the quality of coal is poor or if the stoker runs at a high speed due to overloading of the boiler, the proper combustion of coal may be impaired. Therefore, the arch may get cooled and have less radiant heat with the effect that the fire gradually advances. Question: how will you operate a blow-off valve hooked up in series with a quick opening valve? Answer: the quick opening valve should be opened first, allowed by the blow-off valve. During closing, the blow-off valve is to be closed first and then quick opening valve. Question: what do you mean by the firing regime of a boiler? Answer: heating the water steam and gas pair paths, whereupon the process of steam generation sets and the temperature and pressure of the steam is gradually raised to the specified value. The firing regime is completed when steam is generated at the rated capacity and the steam parameters attain the specified values. This is also called the startup regime. Question: does the boiler startup depends on the normal state of the equipment? Yes. Question: how many kinds of startup are there? Answer: hot startup, warm startup and cold startup. Question: how are these distinguished? Answer: these are distinguished by the length of idle time proceeding startup. For a monoblock unit, hot startup 6 to 10 hour proceeding idle time, warm is 6 to 10 hour to 70 to 90 hour, cold is 70 to 90 hours. For conventional boilers, the difference between hot and warm startups is determined by the preceding ideal time of 6 to 10 hours or more, while the difference between warm and cold startups is by the loss of cage pressure in the boiler and the temperature drop of the hottest element down to 150 degrees Celsius. Question: how can the load pulverized coal fired drum type boiler unit be decreased? Answer: load is gradually reduced on the unit and the firing rate is reduced. If the unit load decreases to the point when the feeder rating on the pulverizer is reduced to below 50% of the maximum, stabilizing fuel oil firing is introduced and one pulverizer is taken out of service as follows. The pulverizer coal feeder rating of the selected pulverizer is gradually reduced to a minimum. When the minimum rating, approximately 25%, is reached, the hot air shut-off gate valve is closed. When the pulverizer coal air temperature drops to 45 degrees Celsius, the coal feeder is taken out of service. The pulverizer is run for about 2 minutes to make it completely empty and then stopped. Question: how can the load on the above boiler unit be raised? Answer: the load is increased gradually and the firing rate is raised. If the unit load is increased to a point where the feeder rating of the pulverizer in line exceeds 80% of the maximum, then the second pulverizer is taken in line as follows. Pulverizer is brought to operating temperature by opening the hot air shut-off gate valve. Pulverizer cold feeder is started at minimum feeder rating. After the cold ignition has been established, feeder rating is increased until the pulverizer loading equals to the other pulverizers in line. Thank you.